All right, hello everybody. I just wanted to go over a couple things on this lab vet simulation. We were having a lot of issues during this morning's lesson, and I completely understand why. Technology can be really frustrating, especially when it doesn't work the way it's designed to. So, also, I just want to go over the physics of this lab. Just some brief examples so that you'll be all set to go with completing your lab on your own and doing all of your predictions, doing all of your, what actually you have to do in the lab, and then explaining what you concurred about that or concluded about it. So I'm going to go over this PhET lab really quick. Again, I'm not going to give you the answers, so if that's why you clicked on this video, you are wrong, but I just wanted to go over this. So this is the PhET simulation. It's called the Moving Man. Basically, we are asked to play around with this position and velocity and acceleration first. So adjusting the position is going to adjust where he is going to be located on this line. Okay? And adjusting our velocity is going to adjust how fast he is going in a certain direction. Again, if it's negative, he's going to be going in the negative direction. If it's positive, he's going to be going in the positive direction. And acceleration, again, it's just the change in velocity over time. So you will see him either accelerating or decelerating, depending if you put a positive or a negative number there. I hope this makes sense. I think it does. Okay, so next thing I want you to do is go to charts. Now charts is super important to us for this lab because it's going to give us some examples of what our graphs are going to look like. So I believe, let's just look, we were asked to move the person slowly at a constant velocity towards the house. So I can recognize that my house is in my positive x axis. So in real life, we have a positive x direction and then a y direction, right? So a y would be up and down, and then the x would be across. But if we needed to graph a position versus time graph, the x would be our time and y would be our position, okay? Or our distance away. All right, so let's look at this. So we are starting from the origin. How do I know we're starting from the origin? Because we have 0 meters. We have 0 meters going in the positive direction. We have 0 meters going in the negative direction. We're just sitting pretty at that origin line. So we are asked to adjust the velocity. And now I told you in lab that we need to keep it at a pretty low speed so that we can get the greatest position and versus time graph. So by greatest, I just mean the best looking, so that we can actually see what the motion of this person is looking like. Okay, so let's just give an example. So I'm going to adjust my velocity to 0.5. Okay, and I'm going to hit play. And now we can see that our person is moving at 0.5 meters per 1 second. Okay, so we can see the time up here. We can see our velocity is not changing, it's constant. And we can see our position. And our position is changing. How is it changing? Well, to know, we'd have to look at the slope. And we discussed in our class yesterday that the slope is equal to our speed. But how do we find slope? It's rise over run. So rise over that run time. So we can see that over a great amount of time, we are going a short distance. Okay, so this is what I am looking for you to do. I want you to take a little snapshot of your position versus time that you found in the lab, and I want you to post it on your lab. Okay, you should already have your prediction there, but now that you have this lab data and that you have your prediction, now I want you to talk about and explain the differences between them. One, and explain what my slope actually means in order for this motion. So what does my slope mean for the motion of this person here? Okay, is it positive? Is it negative? If it's negative, what does that mean? If it's positive, what does that mean? If it's steep, what does that mean? If it's not so steep, what does that mean? Okay, that's all I'm looking for you to do here. And then in the second part of this lab, so let me just restart here. I'm asking you to change the velocity. So what does that mean? We know that acceleration is the change of velocity over time. So really, I'm asking you to adjust its acceleration. Again, you always want to reset to that origin point just so you can get the best graphs and the best data out of your analysis here. So we're going to do that. So we've set our origin point, and now let's choose an acceleration. I'm going to go positive again, so I'm just going to say 0.5. So this is going to be a constant acceleration, but you're going to see that it's going to change our velocity graph and it's going to change our position graph. So let's check it out. So as you can start seeing, there's a little curve to our position versus time graph. And I'll stop it here. There's a little curve to our position versus time graph. This looks linear, and my acceleration is staying constant. So again, for part 2 of this, I just want you to talk about these 3 graphs that you see here and explain them. So we talked about yesterday that the position versus time, if it's curved, it shows acceleration, and that's exactly what we are looking at right now, right? Because we adjusted the acceleration so that we could see what it would look like for the change in velocity over time. All right, so, and then I just want you to go through our post-lab questions, and then there is a last question there that gives you velocity versus time graphs. So something along the lines of this. Now, it might be a good idea for you to reset your moving person here. It's back at that origin place, and try to play with this program to see if you can get the graphs as you see at A, B, C, and D here to look similar to what you would see here. So again, you should be recognizing as we move through the part 2 of this, you should be recognizing that those 3 graphs, they can be looking something along the lines of these, depending on which motion or which scenario you are doing. So I just ask you to rank from greatest to least in terms of velocity at 10 seconds, acceleration, and distance covered. And you can find that information right here. So if you just want to go back and try this out again and see what it looks like in terms of where you are position-wise, where you are velocity-wise, and where you are acceleration-wise, so that you could get the best run data for your post-lab questions. All right, I hope this made sense to you. If you have any questions, please reach out to me. Just remember that this is lab work, not homework. Even if you have to do it at home, it is still counted as your lab. Again, reach out to me if you have any questions, and I'll see you all soon.